So reviewing this practice test should help you with your test corrections for the real test for assessment A. So for number 1, the correct answers here were B, C, and D. But let's see why. So if you remember, we said that corresponding parts were related. So if we look at the explanation, so for number 1, it says quadrilateral ABCD, the little figure, is a scaled copy of quadrilateral EFGH. Select all true statements. So because they're telling you it's a scaled copy, we know that there is a relationship between the corresponding sides. So what I mean is, if we look at this side here, the side AD, that's the side on the left, that has a number 5. The corresponding side would be here on the bigger figure, and that's a 10. So we can see the relationship here that we're multiplying the 5 times 2, because 5 times 2 is 10. So that has to be true for all of the corresponding sides. For example, if this side is 6, I know that the corresponding side is going to be half of it. Right? The reciprocal of multiplying by 2, or the inverse of multiplying by 2, is dividing by 2. So depending on what direction you're going, you're either going to multiply by 2 to go from small to big, or divide by 2 to go from big to small. So to go from the big figure to the small figure, starting with 6, 6 divided by 2 is 3. Let's do this one. We have 4. Half of 4 is 2. There's that corresponding side. And finally, the 8, the corresponding side would be here, and half of 8 is 4. Okay, so that's all of the measurements. Now we can really look and see. So I can tell that A is not going to be the right answer because it's telling me that BC is half of EF. Well, BC and EF are not corresponding sides, so that couldn't possibly be the answer, because here is BC is here, and EF is at the bottom. Those aren't corresponding sides. They have no relationship. So that's why that was definitely not the right answer. I was going to try to erase that, but yeah. Okay. So B says segment CD is half of GH. That makes sense because they're corresponding sides. CD is 4 and GH is 8. So yes, CD is half of GH. So that is why B is a correct answer. Now for letter C, they're talking about angles. And we learned that with scaled copies, no matter how big or how small your figure, the angles don't change. We said in class, if we think about those concrete bricks that make up our walls, I can have a concrete brick or a rectangle. It doesn't matter how big or how small. It could be the rectangular part of a desk, the rectangular floor, the rectangular cinder blocks. They all have 90-degree angles in the corner. Doesn't matter how big or small they are. 90 degrees is always 90 degrees. Therefore, for C, it says the measure is equal. The measure of angle ADC is equal to the measure of angle EHG. I know that's true because ADC, they have to be corresponding angles, of course. ADC is here in blue, and corresponding to that is EHG right here. They're corresponding angles, therefore their measures are equal. And finally, we already did D. We see that the segment AB is 3 units. That's right there in blue. And let's see, E, we learned that area is not half. It doesn't match the scale factor. You actually have to square the scale factor. But we didn't really get too much into that. You just had to know it wasn't the same as the scale factor. So our correct answers here are B, C, and D. And for number 2, the correct answer here is A, B, and E. So it says that a rectangle measures 8 inches by 2 inches. Rectangle B is going to be a scaled copy. Select all measurement pairs that could be the dimensions of rectangle B. So what you had to know here is that your scale factor is the number that you're multiplying by to get your next shape. But remember, you have to multiply every side by the same number. So the numbers we're working with are 2 and 8. The reason why A is a correct answer is because I'm multiplying both numbers by 5. Right? 2 times 5 is 10, and 8 times 5 is 40. So your scale factor is 5. That's not a decimal. Oops. That needs to multiply. For B, I can see that I'm multiplying by, I want to say 1 1/4. Yep, 1 1/4, or 1.25. So 8 times 1.25 and 2 times 1.25 is going to give you 10 and 2.5. I wanted to go back and verify, but that is correct. The scale factor is 1.25. Now, one way I can check it, because you saw me doing a little mental math there, I can try dividing. I can try dividing 10 divided by 8. That gave me the 1.25. And then to make sure it matches, I multiplied 2 times 1.25. To verify, it gave me 2.5. And the same thing for E. Let's divide. Let's say 6.4 divided by 8 is 0.8. And if we multiply 2 times 0.8, we get 1.6. So these match. So the bottom line here is that whatever scale factor you're using, you have to apply it to both numbers. If you're not multiplying both numbers by the same scale factor, then it cannot be a scaled copy. And what we were trying to find were which one of these could possibly be that second rectangle that had to be a scaled copy. For number 3, the correct answer is A. And let's find out how we got there. So we know that this particular rectangle is 5 inches by 6 inches. The actual parking lot is 240 feet long. If we look here, the length is matching the 6. So this is actually 240 feet long. What is the area? That's the trick. They want area. They're not asking you for the width. They want the area. So first, we had to figure out, what are we multiplying by? What times 6 is 240? To figure that out, if you can't do the mental math, that's fine. You have a calculator. You want to take 240 and divide it by 6, and that gives us 40. That is your scale factor, because that's what you're multiplying times 6 to get the actual length. So now, as we learned before, whatever your scale factor is, that's what you have to multiply every number by. So that means 5 times 40, that's 200. So that means the real parking lot, the actual parking lot, the real thing. Remember, we're going from the drawing, which is small, to big, the real life. We have to multiply. That's why we said 6 times 40 is 240, and 5 times 40 is 200. Now, they're not asking you for the length. It would be easy to say, oh, my answer is C, and then move on, which is what I actually did the first time. They're asking you for the area. And remember, area of a rectangle is length times width. And in this case, our length is 240. We just figured out our width is 200. When you multiply those, you get 48,000. And that's why the answer is A. Okay, ooh, that's really hard to see. So for number 4, it says, here's a polygon. Draw a scaled copy of the polygon using a scaled factor of 3. So let me pause this. Let me draw that in. Okay, so now you can see it a little better. I traced the shape and I filled in the lengths. All I did was count how many boxes long each of these sides was. So in the actual test, they're not asking you to draw it, but they are asking you lengths. I believe there's a corresponding question there. So the scale factor is 1/3. As you may recall, we learned that these unit fractions, like 1/3, what ends up happening is that you're dividing. So for example, if we said, remember the scale factor, the scale factor you're always multiplying, right? The word factor even means to multiply. So let's take the side with the 9. I don't know why that's moving. Okay. 9 times 1/3. When we multiply fractions, our whole numbers. Okay, apparently I paused that. My apologies. I don't know what you missed. I was saying I filled in the shape, the sides, and I filled in the lengths. And now we're using our scale factor. Our scale factor means to multiply. And we learned that when we multiply by a fraction like 1/3, where that numerator is 1, this is called a unit fraction. And what happens is we just end up dividing. So now I'm showing you why that is without pausing. So the fraction bar means to divide, and all whole numbers have that invisible denominator of 1. Now when we multiply fractions, what happens is we multiply straight across. I don't know why that's so thick. There you go. So 9 times 1 is 9, and 1 times 3 is 3, and that fraction bar means divide, and 9 divided by 3 is 3. So as you see, when we multiply by 1/3, what we're really doing is just dividing. So what they want you to do is determine the lengths of these, okay, I can't get rid of that, of each side. So what I'm thinking to myself is, well, 9 divided by 3 is 3. Let me use a different color. That's pretty. 9 divided by 3 is 3. So if I were to draw a different figure, this side length would be 3, and the bottom length would be 3 also, because 3 divided by 3 is still 9. 6 divided by 3 is 2. 6 divided by 3 is 2. 3 divided by 3 is 1, so each of these would be 1. And that's how you would know how to draw your scale figure. So I can draw it real quick. Let's see. I got a length of 3, a length of 2, go down 2, over 1, down 1, and over 3. So these figures, the red one and now my little blue one, they're scaled copies, and the little one is 1/3 the size of the bigger one. So for number 5, we're going to use cross products to figure this one out. So first, let's take our scale, which is here in the actual question, 8 centimeters. I'm trying not to pause this again. They make it tricky. All right, 8 centimeters is in ratio to 5 kilometers. This is your scale. And now we're looking for an actual distance of 8 kilometers. So I'm going to set this equal to, because we're making proportions, 8 kilometers. Now, in my original, I had kilometers in the denominator, so I need to put kilometers in the denominator over here also. And I'm going to use x to represent the centimeters, because that's what we're looking for. So now we learned that cross products are equal, so we're going to multiply across. 5 times x is 5x. And we multiply across the other way. 8 times 8 is 64. And then our last step is to figure out what times 5 is 64. So to do that, we divide both sides by 5. And we figured out that x, right, these canceled out. 5 divided by 5 is 1, so we have x by itself. X is equal to 64 fifths. We could leave it like that, that'd be fine. 64 fifths. If you had a calculator, you can divide this and get a decimal answer. It'd be 12.8 centimeters. That's how you solve the first one. Now we're going to use the same scale to figure out part B. See, now they're giving you centimeters. So let's use our same ratio. We have 8 centimeters, running out of room, 5 kilometers. It's late. 5 kilometers. Now this time, instead of my x being in the numerator, I know what my numerator is. It's 5, because that's centimeters. So 5 centimeters in the top. Notice that it matches, right? So if I have centimeters here, I have to have centimeters here. They always have to match. Centimeters on top, just like here. Oh my goodness. Kilometers is on the bottom both times. So we're going to do the same thing here, except that's what I'm looking for is my kilometers. I said it right that time. So we're going to cross multiply again. 8 times x is 8x. 5 times 5 is 25. Our last step is to divide both sides by 8. And we get x is equal to 25 eighths. Or you can divide, right? You have a calculator, 3.125. And that is kilometers. There you go. So remember, these questions are corresponding to the ones on the actual test. So for this problem, because they're not giving you those unit fractions, we had to do the cross multiplying. Okay, let's move on to number 6. Number 6, I think was, in my opinion, number 6 was the most challenging because they're giving you 2 different maps with 2 different scales. Right? So it tells you, number 6, there are 2 different maps of California. On the first map, the scale is 1 centimeter to 20 kilometers. So there's your first ratio. Let's fill that in. It said 1 centimeter to 20 kilometers. Let's see. The distance from Fresno to San Francisco is 15 centimeters. So we know that's going on. And then there's a second map, right, where they're telling you it's 1 centimeter to 100 kilometers. I keep doing that. Kilometers, sorry. They want to know the distance from Fresno to San Francisco on the second map. So what we're going to do is use the first map and change the centimeters to kilometers, and then on the second map, go from kilometers to centimeters. Okay, so let's go with the first one. We're going to put 15 centimeters here. We don't know how many kilometers yet. Again, we cross multiply. X is equal to, and then 15 times 20, I believe that's 300. Okay, so that means for the first one, that means that the 15 centimeters means 300 kilometers, I got it right, in real life. Okay, but that's just the first part of the question. We have to take this important piece of information and now using the second scale, convert it back to centimeters. So let's use our scale. Go back to blue. We had 1 centimeter is equal to 100 kilometers. We're looking for centimeters, right? Because that was the question. What's the distance on the second map? So on the map would be centimeters. So I'm going to put the X there. And let's see, we know that the scale, we're looking at 300 kilometers. That 300 came from the first map. Okay, cross multiply again. 100 times X, I'm going to run out of room, is equal to, so I just multiplied here, it's multiplied that way, is 300. Divide both sides by 100, just like we did before. We get X equals 3, which means that the distance between Fresno and San Francisco on the second map is 3 centimeters. Ta-da! Okay, for number 7. You see I moved a little bit up there because I ran out of room. But anyway, so our scale is 1 to 40. In this particular kitchen, oops, that didn't work. This particular kitchen is a rectangle, and it's 2 meters by 6 meters. And we have a scale of 1 to 40. Now, because of that 1, we don't need to do the cross multiplication. We could, but we don't need to. Because in this case, we're going from real life, right, the real sized kitchen, to the scale drawing. So we're going from big to small. And because it's a unit fraction, all we have to do is divide by 40. So I'm going to take 6 divided by 40, and I'm going to take 2 divided by 40. This is the result of cross multiplication. If you recall at the beginning, when we were looking at multiplying by 1/3, right? Do you remember that part? It's the same thing. That's why we're allowed to divide. Right? But when we go from small to big, we're going backwards. Just like in that number 1 problem when we were looking at the big figure and the little figure, and depending what direction you were going, you were either going to multiply by that scale factor or divide. It's the same thing here. But anyway, I digress. 6 divided by 40 is going to give you 0.15. And we started with meters, so we still have meters. And then 2 divided by 40 is 0.05 meters. So those are going to be the dimensions of her kitchen on the scale, on her, not her map, but like her drawing, right? It says she has a scale drawing, her kitchen is 6 meters, and then drawing label for the scale drawing. Yep. So that's how long it would be on the drawing. So it'd be much smaller, and instead of 6, it would be 0.15 meters, and this would be 0.05 meters. I mean, we'd probably want to convert that to centimeters or even millimeters, but for our intents and purposes, that is sufficient. So I moved things around a little bit. Sorry about that. Running out of room. So we're still talking about May's kitchen. So we still have the same scale, which originally was 1 to 40. So that's still the scale. Now this time we're talking about the door. The door is 1.2 meters wide, and they want to know what it would be on the drawing. Remember, we're going from big to small. So just like we saw before, we're going to take that 1.2 and we're going to divide by 40. That's what that tells me. And because we're going from big to small, that's why we divide. So if I were to divide 1.2 divided by 40, oh goodness, there's a 3 in there. Hold on. Let me get my calculator. 1.2 divided by 40 gives us I was right, 0.03. It's late, guys. Well, let's see, what unit are we using? Meters, so there's meters. So that would be the answer to that one. Any questions on that? Okay. If I did want to change it to centimeters, I would move the decimal twice because there's 100 centimeters in a meter, so that would be 3 meters. But you can leave it here. That's fine. Now, we're going the other way here. For part C, they're giving you the measurements of the drawing, and they want to know what it is in real life. So in this time, instead of dividing by 40, we're multiplying by 40. Again, think of problem number 1 on this practice test when we were looking at the 2 shapes, and I showed you how going one direction you multiply by 2, but the other direction you divided by 2. It's the same thing here. If you had the real kitchen and the drawing of the kitchen, well, we're going from the drawing to the real table. It's getting bigger, so we have to multiply. So I'm going to take 4. Oops. I lost what I was doing. You're going to take 4, and this time we're going to multiply. So if I have 4 centimeters times 40, and then I'm going to have 2.5 centimeters times 40. 40 times 4, that's going to give you 160 centimeters. Of course, if we wanted to change it to meters, we could make it 1.6 meters, but you don't have to. And then 2.5 times 40. Ooh, I don't know that one in my head. Certainly not at this hour of the night. Times 40 is 100. Oh, duh, I should have known that. Is 100 centimeters. And in real life, 1 meter. That's it. Those are all the test questions. So these do, again, correspond with the test. Not only do they correspond with the test, they correspond directly. So number 1 on the practice test, you're going to use the same strategies to answer number 1 on the real test. Number 6 on the practice test is going to be like number 6 on the real test. I think for number 7 on the real test, I think that's the one they break up. There's 1 or 2 questions on there that instead of having like part A and part B, they made them separate numbers. But in general, it's the same. It's the same lineup. Okay? So good luck with your test corrections. And I look forward to scoring those and updating your grade in the grade book. Good luck.